We're supposed to draw this graph using Newton's software. And so they say t equals negative 3 pi over 4 and t equals 0. I think the only thing we can do is plug those in. I'm not sure how the grabbing and dragging feature is going to work, but let's check it out. Let's start with negative 3 pi over 4. We'll plug that in for t. So x of negative 3 pi over 4, plugging that in for t, that equals 3 times tangent negative 3 pi over 4 plus 1. And then if we're trying to figure out negative 3 pi over 4, we can draw that for tangent. So negative 3 pi over 4, you can convert that to degrees if you're a little unsure of your radian measurements. And the way you do that is you cut out the pi and you multiply the fraction times 180. So it's negative 135 degrees. So positive angles rotate this way. Negative 135 lands us right here. So that makes 45 degrees before we complete the semicircle, right? That's 135 plus 45 makes 180. And you always make a right angle with the x-axis when you draw these triangles. And the convention is to draw them in the unit circle, which means that this is the edge of the unit circle. So this is a hypotenuse of 1. So that means this is going to be negative square root of 2 over 2. And it's negative because we're going down on the y-axis, right? And then this is also negative square root of 2 over 2. And now we're ready to say what tangent of negative 3 pi over 4 is. Tangent is opposite divided by adjacent. So the opposite divided by the adjacent is just positive 1. So this is 3 times 1 plus 1. Okay, so when the parameter t equals negative 3 pi over 4, we got an x value of 4. So that means this dot should be moved over right around here. I don't know if the graph changes with the dot, but we at least know that the x-coordinate is supposed to be 4 when t equals negative 3 pi over 4. Okay. So we need to plug in negative 3 pi over 4 in for y, I guess. And if you do that, that's just going to confirm that it, 1, 2, it's probably like 2.7-ish, something like that. So if you plug negative 3 pi over 4 in here for y, for the equation of y, negative 3 pi over 4, we've already got that angle drawn, right? That's right here. And cosine is the adjacent divided by the hypotenuse. So cosine of negative 3 pi over 4 is negative square root of 2 over 2. This is all negative, this term. And that's just confirming what we thought, right? Negative 3 square root of 2 over 2 plus 1, that's going to be roughly 2.7-ish. Oh, wait, sorry, that's going to be negative. It's going to be down here. I dropped a negative sign. Okay, that wasn't making sense. It should be a positive like we drew it. It's because I dropped this negative sign. So negative times a negative makes a positive here. So here we can convert that to a decimal. Square root of 2 divided by 2 times 3 plus that 1. That's a little bigger than what the graph is suggesting. I don't know, maybe you can drag it up or something like that, but this dot should definitely be over here. When t equals negative 3 pi over 4, the dot should be at positive 4 on the x-axis. And it looks like the y dot should be up a little bit. But maybe Newton, because I don't have access to the graph, or maybe Newton's going to move that up when that happens. Okay, so that is t equals negative 3 pi over 4. We just have to plug that into both. T equals 0, we want to plug that into both as well. So if I plug in 0 in for t into the equation that spits out our x-coordinates, if you're not sure what tangent 0 is without a calculator, tangent is sine over cosine, right? So 0 degrees is right here. Sine is always the y-coordinates of your terminal side, and cosine are always the x-coordinates. So cosine is 1, sine is 0. So tangent of 0 is 0. So 3 times 0 is 0. 0 plus 1 is 1. So the x-coordinate should be 1. So it looks like this student has this part correct. At x equals 1, tangent, t equals 0. That's correct. And then you want to plug it in to find out what the y-coordinate is. And if this student has it right, the y-coordinate should be -2 when we plug it into the equation for y. So if I plug in 0 in for the parameter for y, I get -3 times cosine of 0 plus 1. So cosine of 0 is 1. -3 times 1 is -3. So that makes -2. That checks out. This is the correct dot for this one. Okay, so this one just needs to be dragged over to t equals 4, it looks like. Unless I drop something on that one. No, that looks good. Okay, so that's it. So with these questions, you're plugging in the parameter that Newton is forcing you to use. They say t equals -3 pi over 4. We'll plug that in for x, and the x coordinate we got was that it was supposed to be 4. So this is over here at x equals 4. And then plug in -3 pi over 4 in for the parameter in the y equation, see what the y coordinate is supposed to be.